Hello guys and welcome to episode 10. In this episode we're going to be solving two problems. One of them is vertical facing, making quote look up and down, and additional sprites for our jump animation. So, our problems in this episode are the jump animation. Right now it's using the standing sprite and the walking animated sprite, and it needs its own pair of sprites. It's actually two static sprites. And the first sprite is when quote is jumping or going up, and that's going to be just the second frame from our walk animation. And the third frame from our walk animation is going to be used for falling. And the other problem we're going to be solving is we need to keep track of which way quote is facing, up, down, or horizontal. And this means we're going to add a little bit more state to our player class, and it's just going to be a vertical facing, much like our horizontal facing, and it's going to be either up, down, or sideways, and we'll call this horizontal because I like horizontal better. And then we're also going to need to add our vertical facing to our sprite state because that is going to be determining which sprite we're using. And then we're also going to need to add these new sprites into initialize sprites. So most of this, we've done most of this kind of stuff before, so I'm just going to jump right into it. So let's start with our jump. I'm going to go into our player H file and add a couple of new motion types. Right now we have standing and walking, but we also need to have jumping and falling. So now that we have those, let's go to our initialize sprites method and add in our new jumping sprites. So these are going to be static sprites. I'm going to start with the left side, and I'm going to copy and paste our standing sprite because it's very similar, and just change what I need to. First of all, it's not standing we're talking about jumping. We're jumping left. Everything else looks good, except for here we need to, instead of doing 0 for our frame, we need to do frame, our k jump frame, which we'll define pretty soon, times our tile size. Game k tile size. And we need to do a similar thing for falling. And the only difference here is instead of k jump frame, it'll be k fall frame. And you're probably noticing that this is getting pretty boilerplatey. We're going to fix that in this episode, so don't worry too much about that yet. But I just want to get it compiling and running and make sure it works before we start refactoring. So now that we have left jumping and falling, let's add right jumping and falling. Again, this is very boilerplatey, but we're going to fix it. So instead of 0, or here, let's change our lefts to be rights. So instead of left, s left with right. And instead of 0, we're going to be using game k tile size. And that's because we're using our right frames instead of our left frames, which is exactly one frame below our left frames. So let's make sure that this compiles really quickly. We're missing our k jump frame and k fall frame, so constant k jump frame. It's going to be the second frame, but since we're 0 based, that means we're 1. And our fall frame is going to be the third frame, so that's going to be 2. So let's see if this compiles. And it compiles successfully. Now we need to actually use our set our sprite state to use jumping and falling. Right now, this is where we set our motion type for our sprite state, and it's only set to be standing or walking. So I'm going to extract this out, motion type motion, and define it before we return a new sprite state. So the first thing we need to check is if we are on the ground, then we can use this bit of logic here that we've already written, and that's the acceleration x equals 0.0f. So let's move that up here and set motion equal to that, and motion is this variable I just defined here, and we'll return and we'll use motion to define our sprite state instead of use motion to define our sprite state instead of just a couple of nested ternaries. So if we are on the ground, use this acceleration x to determine our motion type. Otherwise, we are in the air, and we need to say motion is either going to be jumping or falling. And so how do we know if we're jumping? Well, we're going to say that we're jumping if our velocity of y is greater than, or less than or equal to, or just less than 0.0f. Because remember, up is negative y. And so that's going to be our check for if we're jumping or falling. And this should be all that we need. Let's make, just to make sure everything compiles. It does. And I'm going to show you what this looks like. So make run. And we have quote. And if we jump, you see he kind of sticks his legs. He does his legs out differently. And then when he lands, he switches again. And you can see as he's falling, he's switching frames. So this is all good, perfect. And I'm walking as I'm in air, but he doesn't switch frames, which is also good. All right, great. Before I edit the code much more, I'm going to make a quick change to our SDL screen creation. So let's go to graphics CC. And instead of having an SDL full screen, I want it to be windowed, so I'm just going to pass in 0 or null for no flags. And this is just so that if it happens to crash or freeze while I'm in it, I can switch over to the terminal and kill it if need be. Implicit conversion. Okay, so I'm actually going to use 0 instead, graphics of null, because I got a warning for that. There you go. Now we can go to our player class, and right below our start moving left, start moving right, stop moving, we're going to have our looking handlers. So look up, look down, and look horizontal. And I'll define these in the CC file right below our stop moving. Do some Vim magic, delete word. And then we can go to our games class and actually call these methods. And the logic's going to be really similar to our horizontal movement logic, because if we have a collision of keys, like if they're pressing up and down at the same time, then we don't want to do anything. We want to look horizontal. So I'll just change STLK left with up, right with down, and stop moving will now be look horizontal. So up, look up, right, goes to down, move, look down, and look horizontal. And so let's compile, make sure that this works. It does. Let's implement these new methods, if I can type. So we're going to need an enum for vertical facing, and it's going to be up or down or horizontal. And we're going to keep track of that like we're keeping track of horizontal facing. So CFL vertical facing, CFL vertical facing. And let's remember to initialize it in our constructor right below horizontal facing, CTL vertical facing horizontal. We also need to add it to our sprite states. Actually, before we do that, let's implement these look up, look down, look horizontal methods. And these are going to be pretty trivial right now just setting vertical facing to be equal to up for look up, down for look down, and look horizontal, or horizontal for look horizontal. So yeah, pretty trivial for now. We're going to add more logic later though. We will also need to update our sprite state class because we have different sprites for whether we're looking up or looking down. So I'll add a vertical facing field called vertical facing, and we'll put it in our constructor vertical facing and have it default to horizontal, and of course initialize our vertical facing. A lot of stuff to do. And then one more thing, and this is important because if we don't do this, multiple sprite sheets or multiple sprites will collide with each other in our math, and we don't want that. So we need to update our less than operator. So this will be the same logic as our horizontal facing, except instead of horizontal, it'll be vertical. So just change all that, like so, and this should compile as it is. And just to make sure it's still working, yeah, we have quote. He's moving back and forth. I'm pressing up and down, but since we default to horizontal and we're never changing that in get sprite state, we aren't trying to use uninitialized sprites or anything like that. Now we are going to kind of clean up our initialized sprites and at the same time add new sprites. So let's go to player.h. I'm going to make another function right below initialize sprites, and it's going to be just called initialize sprite. And it's also, in addition to a graphics object, it's going to take in a sprite sheet object, and that'll be a const sprite sheet object. Well, a reference to a sprite sheet object. So, not sprite sheet, sorry, sprite state. So we'll call this sprite state. I'll go and define it, and I'll show you what we're going to do in a second. Right below, this is our massive sprite state, initialize sprites function up here. So right below that, I'm going to put initialize sprite. We'll put this in view. Okay. So what we're going to do is, you can see we have all of these different calls, and instead of having a list of calls, I'm going to loop through every possible situation. And this way we don't miss any situations. Because what happens if you are in a state that you haven't defined a sprite for, you'll get a null pointer exception from our scoped pointer or shared pointer, and yeah, that'll crash the game. So I'm just going to write pseudocode for now. So this will be for every motion state, or every motion type. And then inside of that, nested for loop will give us every combination. So for every horizontal facing, and then again for every vertical facing. And what we're going to do is we're going to create a sprite state with these three, with the motion type, the horizontal facing, and the vertical facing. And then we're going to call initialize sprite with that sprite state that we create. So hopefully this makes sense why, and if it doesn't make sense why we're doing this, you'll see in a few minutes like how much this really helps clean things up. So in order to do these for loops, we have to do a special trick with our enums, and this is a pretty common trick, so I'm just going to tell you about it. But if you want to look up, like, everybody complains on Stack Overflow, like, how do I make a C++ enum loop over enum values? And this is one way to do it if you don't set the values for these enum types. So like if I were doing 0.38 and 0.72, this trick wouldn't work. It's just like if you're doing the regular integer increment thing. So anyway, what you do is you say first motion type, and then you set standing equal to be the first motion type, and then these will increment, and then you also have to have a last motion type. And now I'll show you what the for loop looks like. So for, and then you say motion type, we'll just call it motion type, equals first motion type, and then you say while motion type is less than last motion type, and then you can do plus plus motion type. Since it's an integer type under the hood, plus plus is acceptable. So this will take care of for every motion type. Now let's look at horizontal facing and do the same thing. So we'll say first horizontal facing and last horizontal facing, and then set left equal to first horizontal facing. And then I'll do the vertical facing again really quickly. First vertical facing and last, and then set up to be the first. And it doesn't really matter which one of these is the first, it's just happens to be at the top, and so it's whichever one's at the top gets the first vertical facing. So I'll make these a couple more nested for loops. So for horizontal facing equals first horizontal facing, and horizontal facing is less than the last horizontal facing, plus plus horizontal facing. And I'm going to copy and paste for the vertical facing just to make things a little bit faster. So instead of horizontal, it'll be vertical. Instead of lowercase horizontal, it'll be lowercase vertical. That might be a better way to do this. Instead of all capital horizontal, it's all capital vertical. Yeah. And now I'm going to call initialize sprite, with our graphics and with our sprite state, which we're about to create, and that'll be, it'll have as its first parameter the motion type, and then it will have the horizontal facing, and then it will have the vertical facing. So let's make sure that this compiles. It doesn't compile yet because I am missing a parenthesis. Now let's see if this compiles. And it does. Let's move stuff into our initialize sprite method. Player cc. So this is going to get some of the logic that's up here, but I'm not even going to look at this while I talk about the logic in here. So I'm going to start out with the source X and the source Y, and this part is going to be pretty heavy on logic, so if you have trouble understanding it, I encourage you to type it in yourself to really just kind of understand what's going on. And typing it in yourself is really the best way to sort of absorb the material. At least it is for me. I don't know how you think, so whatever works for you. But let me let's talk about source y first. Source y is going to be one of two things. It's going to be either 0 if we are going left, or it's going to be game k tile size otherwise. And this is actually not quite true. Like in the case where we want to use a quote that is not in the top left corner, or we want to use a quote that's like maybe 8 tiles down or something, this is not going to be 0. It's going to be the character frame, so we could call it the character frame times the tile size. And that's what we're going to do. But we're going to have our character frame be set to 0. So I'm going to make that constant k character frame. And this is like if I set it to like 8 or something, I would get the Halloween version of quote that is in that bitmap. So I don't actually know, I made that number up. Anyway, so source y is going to be this if we're going left, otherwise it's just going to be this character frame times k tile size plus 1. And it'll be the character frame plus 1 times k tile size. So I'm going to go ahead and fill this in just because it's super simple. And this is just going to be if sprite state dot horizontal facing is equal to left, then we are going to say that we are going to use k character frame times game k tile size. Sorry, that's the wrong operator. Should be a question mark. Otherwise, we are going to do 1 plus k character frame times game k tile size. Okay, so that's the y. Now for the x. And I'll just put that after that. And so the x is a lot more complicated. So there's a few conditions. Like it depends. At least we know it doesn't depend on the horizontal facing, but it does depend on the vertical facing and on the motion type. And if we are so let's handle the horizontal case first. In the horizontal case, we're just going to do a big switch statement, and this is going to be on sprite state dot horizontal facing. Okay, so let's list all the cases and then go back and fill them in. So case walking, case standing, and I'll go ahead and put breaks in, I guess. Case jumping, case falling, and I said breaks, and then there's also the case that we never have to handle, which is case last motion type, but I'm putting it in for completion's sake. For case walking, it's just going to be the 0th frame, but I'm going to make a constant for it just to be extra clear. This is k walk frame times game k tile size. For standing, I'm going to do the same thing except use a stand frame. Jumping, same thing, but we already have a jump frame defined up here, and that's at 1. And then falling, we'll use our fall frame. So this is the horizontal case. I'm going to define these to the k walk frame equals 0 and k jump frame also equals 0. Okay. Now there's another case besides horizontal, and that's if we're facing up. And I'm going to look at our image. So image contents, my chart. There we go. My char .bitmap. And while I'm here, let me just show you, like, this is character 0 up here, and this is character frame 0. This is 2, 4. That's what I meant. So like as you move down, you can change which character you're using. So that's why I'm using K character. I'll show you in a minute. Anyway, so here's quote walking, and he's walking to the left, and he's looking horizontally. And then if you add 3 frames, you get the same walking and jumping and standing stuff, except he's looking up. And so what we're going to do is we're going to just add an offset to an offset in frames to source X if he's looking up. So say source X is equal to, now if sprite state dot vertical facing is up, if that's the case, then we want to set source X equal to source X plus, and then we'll say K up offset X. This is just going to be 3 frames. Actually, let's call it K up frame offset, and we'll multiply that times game K tile size. Otherwise, we don't affect source X. I'll talk about the down case in a minute too. That's special because you can't look down while you're walking. Okay, so we have this source X, but we don't have a K up frame offset. We'll put one in here, K up frame offset. And we'll set that equal to be 3 because you have to add 3 frames to get the up look. Okay, now one more thing I'm going to do before we're trying this out, and that's actually set our sprite, update our sprite map. And we have to do it differently for walking than for jumping, falling, and standing, and that's because walking is an animated sprite and not just a regular sprite. So we can say if sprite state dot motion type is walking, then we'll create an animated sprite. Animated sprite. Otherwise, we will create a static sprite. So what's our static sprite going to look like? Well, let's jump up here and just steal it. Okay, so we have a sprite state. We don't need to create a new one, so let's change this to our sprite state. And new sprite, everything looks good, except we need to change these values to be source X and source Y. Okay, so now we have our static sprite. Let's go up and steal our walking sprite. Indent. And right here we can just say source X and source Y. Alright, now I want to see if this compiles. It doesn't because I don't have a K stand frame. Of course not, I have not defined it. So let's change K walk frame to K stand frame and see if that works. Case value not enumerated in type. I probably spelled something wrong. Case last motion type, case falling. What? Hold on, let me see what that says. Case value not enumerated in line 201. Yeah, okay, so I didn't mean to say sprite state.horizontal facing, I meant to say sprite state.motion type. So if that was really throwing you off, or you were just thinking I'm an idiot, then you're probably right. Now let's make. Okay, it compiles. But one more thing we need to do. We have all these sprites being reset, and we don't need to set them in here anymore. So let's get rid of that. All of these sprites inside of initialize sprites. We don't need to initialize any more sprites in initialize sprites. We shovel all the work off to initialize sprite. Okay, and yeah, I want to see how many lines this is before I do anything else too, not including constants. So now it's 42 lines, so that's a pretty good reduction. I mean, although we do have our loop, which is quite sizable at 15 lines, I think it's much cleaner this way, and we're handling more cases too. Yeah, so I'll make, and let's try it out. So let's make run, and let's try walking, and oh! Yeah, so this is what happens if you don't have a sprite defined. So let's see what I did. So let's go into player CC, and oh, I see the problem right here. Yeah, I'm using sprite state walking right. This should be the sprite state that gets passed in. Okay, let's see if there's any other mistakes. Okay, let's see. This k-jump frame should not be redefined in here because we have it defined up here. Okay, anything else? Anything. There probably is, but we're going to call it that. Make run. Okay, we can walk now, and I'm trying to push up, but nothing's happening. And the reason is we haven't actually started, not graphics, player CC. We haven't, in our get sprite state, we aren't actually using our vertical facing. So if we start using vertical facing in our get sprite state, instead of using the default horizontal value, we should be getting something. Make run. And we shouldn't have any, I'm pressing down, and we haven't like implemented the sprites for down yet, but this should be fine. Now I'm looking up, and I'm jumping, and I'm looking up, and everything looks good. Sweet. So good. So good. Look at that. Beautiful. Now let's implement looking down. Player CG. Okay. This is going to be an initialize. That's a hard word to spell. Initialize. There we go. Inside of initialize sprite. So there are 3 cases. If we're walking, we don't change anything because you can't look down while you're walking. Okay, now if you're standing, what you want to do is, if we look at content monochar.bitmap, we want to use this this looking back frame. And that's because you can't look down really while you're standing, but you can kind of interact. And when you interact, you look back. And we're going to think of that as looking down while you're standing. So that's the 7th frame. And then here is where quote is looking down while he's jumping. And that is the 6th frame. So let's keep that in mind. So we'll say source X. No, we won't say that. If sprite state dot vertical facing is down, and that's in this else case of not walking, then we want to say that source X equals, now if we're standing, sprite state dot motion type equals standing. If we're standing, then we use this stand frame, k stand frame. No, we'll call it the k back frame. And otherwise, we want to use the k down frame. And let's define these up here. const int k down frame, and that's going to be 6, and back frame is 7. Let's try this out. Make run. So I look down, and he turns around, and he looks back, interacting with his environment. Now I jump and look down, and he's looking down, and I walk and I look down, and he's not looking down, which is perfect. Jump and look down, now he's looking back. Perfect. So perfect. Okay, enough of that. Now let's look at our player class again, because I want to make a few final cleanups. One of them is the fact that we're using this content mychar.bitmap, and I would rather this be a constant so that we can change this easier, and it'll be at the top of our file. So I'm going to bring this up. We'll say const standard string k sprite file path, and down here put k sprite file path, and down here too. And then these two variables, I'm going to bring these out into constants. This one is k fps, it's 15. This k walk fps. And this 3 is k num walk frames. And I'll bring these up here too. It's 3, and k walk fps is 15. Now, what next? Compile. Still compile. So I'm going to take these, all these constants, and put them up at the top, just so that we have a central place for all of our constants that we use. And I'm also going to kind of organize our constants a little bit. It's not that big of a deal, but I like to have things organized. So these are going to be our jump motion. No, this is going to be our fall motion. I'm sorry, fall motion. This is going to be our jump motion. Up here, we're going to have our walk motion. And then here we'll have our sprite frames. Up here is just generic sprite stuff. Our walk frames, our walk animation. So character frame is going to be kind of separated from the other frames because it's in a different direction. It's in rows, not columns. So our walk and stand are going to be up top, jump and fall after that, up frame offset 3, down frame and back frame. Okay, I think everything looks good. I'm going to do a quick scan, see if there's anything else I want to do in this episode before I let you guys go and live your lives. I think that's it for this episode. So let me make, yeah, it all compiles. Thanks again for watching, guys. I really appreciate it. And stay tuned for episode 11, where I begin collision detection. Woo!